Hello everyone. In this particular video, we will see the paper analysis and memory based question of CSIR NAT June 2024 Chemical Science. How was the paper? Paper was actually not very easy. If you are prepared only two part of the chemistry, like inorganic physical, inorganic organic, physical organic, then you will find this paper actually tough. Surface level paper preparation, exam preparation will not work here. You need the deep understanding of the concept. So let's start with the paper analysis. Paper was actually on the moderate side. Part B, the relative difficulty level of the parts, like inorganic was the toughest, then organic, then physical. If we talk about inorganic chemistry, inorganic was not like very straightforward. You know the concept, you will use the concept, then only you can correct the tick, then you can only take the correct option. Or organic chemistry, you need the deep understanding of the concept. You have to know the GOC as well as stereochemistry. Then you can find the paper very easy, and you will able to uh, approach the questions. Physical and chemistry was not very easy, not very tough. It was on the moderate side. You know the concept, you know the formula, then you can easily go with the question and take the correct option. If we talk about the part C was actually organic was little bit difficult. An organic question was doable, then physical chemistry. In the part C, you can easily take the 20 questions very easily. You are able to do, because 20 question was doable out of 60 question. If you go from 20 to 25 question, you will find some difficulty here. And if you talk about the part B, about the out of 40 question, 15 to 20 question was very easy. If you talk about the part A, out of 20 question, you can easily do the 10 questions. So this was about the paper analysis of the CSIR NET June 2024 chemical analysis, chemical chemistry, chemical science. About the memory based questions. So in the memory based questions, the first question, like this is the question from the inorganic chemistry. This is question is involving this particular reaction. The question was like this reaction is involving which type of mechanism. So in this particular mechanism there is out this question will involve outer sphere mechanism by Cn minus mediated electron by net chemical reaction. So this was the right answer. When we in this particular question, the question was that rate of reaction will depend on the concentration of both the substrate as well as on the reagent, or only on the reagent, or only on the concentration of the substrate. As we are able to see here that this reaction is not, in this particular reaction there is no ionizable proton in the substrate. It means the reaction will only depend on the concentration, rate of reaction will only depend on the concentration of the substrate, right? And when we are talking about the stability of this product, as we know that what is Nor-Bornell, this is actually the Nor word. Here is alpha. If we attach chromium here, this is beta, and this is 4, right? When we talk about the beta elimination here, if beta hydrogen will eliminate here, there is formation of olefin, and according to the Brett's law, there is no stability of the olefin and the positive charge at the bridgehead position. It means there will not be this alpha, there will not be this beta elimination, and because of that, this is stable. In this particular question, there is a iso level of borane. As we know, this element tellurium is actually of oxygen family, so we can write BH3 here, and there is B9H11. So this can be written like B10H14, which can be written like B10H10 of H10 4 minus. So as we know, this is actually the nidoborane. So answer would be the Nido boron. When we are talking the covalency in this IF7, SF6, PF5, SiF4, so the answer will be like this. Okay, this compound. So when we are talking about the titanium 4 plus, titanium 4 plus have the electronic configuration D0. So there will not be the DD transition that can be, so the answer would be LMCT, means there will be ligand to metal charge transfer. When we are talking about the VH2O6 3 plus, uh, here we are able to see V3 plus, so there is DD transition because of D1. When we are talking about this, and when we are talking about this compound, so this is D5S0, it means there will not be the DD transition. But uh, when we are talking about the Fsnal, so the order would be, if we are, this is 1, this is 2, this is 3, this is 4. The 4 will have the lowest Fsnal, the first will have the highest, then the third, and then the 2. This will be the order of the molar extension coefficient. So there is another question about the, that was asked from the bioinorganic chemistry. There was some different type of compounds like acetylene hydratase, urease enzyme, carboxypeptidase, sulfide oxidase. This is very easy question when we are talking about the element which is present at the central atom in this compound. So the answer would be like, in the acetylene hydratase there is tungsten, in the urease enzyme there is nickel, Ni, in carboxypeptidase there is zinc, and in the sulfide oxidase that there is molybdenum. Sodium yellow line electronic transition. So as we know that the sodium has the atomic number 11, electronic configuration 3s1. So the term symbol for this would be 2s1 by 2. And when we are talking about the allowed electronic transition, so allowed electronic transition would be 2p3 by 2 and the 2p1 by 2. So the correct answer would be 2p1 by the electronic transition from the 2s1 by 2 to 2p3 by 2, and from this to 2p1 by 2. When we are talking about the next question, the question was, this is the actually the reaction when we react this compound with the AgNO2, there is AgNO2, there is formation of this compound. The question was that what is the charge on the, what is the oxidation state and what is the formal charge on the nitrogen. So oxidation state in this case, when we are talking about the structure, this is actually the case in this particular compound. So there is positive charge here. So the oxidation state would be 3 plus 3. And when we are talking the formal charge, the formal charge will be plus 1. So this is the right answer.